Please title these notes Derivative 6 Notes, Quotient Rule, and write today's date. At the end of this lecture, you should be able to use the quotient rule. So the quotient rule has a lot of similarities to the product rule that we looked at yesterday, but quotient means division, so instead of talking about multiplication, we're going to talk about division. Basically, we have some situation where we've got some function f of x divided by some other function g of x, and we're taking the derivative of that and figuring out what it equals. And in this case, we've got a similar pattern with that f prime g and that f g prime. But instead of addition, we have subtraction. Also, instead of it just being this, it's got a g squared in the denominator. If you want the simpler version without all the x's, you could also write this as f prime g minus f g prime over g squared. This actually comes directly out of the product rule, but in order to show where that comes from, we have to use something that we haven't learned yet. So we'll come back to that in a couple of lessons. But for now, this is what you really need to remember. F prime g minus f g prime over g squared. This negative is sort of coming from this g of x having sort of a -1 exponent if we sort of rewrote it as f of x times g of x to the -1 power. And this g squared comes from taking the derivative of something with an exponent of -1. Using it, however, let's look at that. So let's start off by finding the derivative of 5x minus 2 over x squared plus 1. And so here we have our f up in the top and our g down on the bottom. So we're going to use our derivative of f times g minus f times the derivative of g over g squared. So let's fill that in. Derivative of x, a derivative of f, 5x minus 2. Here's our other f, 5x minus 2. Here's our g, x squared plus 1, derivative of x squared plus 1, and then x squared plus 1. So now all it's going to be is a bunch of kind of nasty simplifying, but it's nothing really that much more intellectually complex than what we were doing yesterday. We take the derivative of 5x, that's just plain old 5, derivative of -2 is 0, x squared plus 1 is along for the ride, minus 5x minus 2, derivative of x squared is 2x, derivative of 1 is 0, and then all of that over x squared plus 1 squared. We distribute 5x squared plus 5 minus, in parentheses, 10x squared minus 4x. Watch out here. Make sure you have this in parentheses because this has been distributed, but the negative has not. The negative still needs to be distributed here. All of that over x squared plus 1 squared. We're actually not going to simplify this denominator, not going to square that out. There's a convention basically that we leave things that are in the denominator that are squared just like they are, just in case something cancels out later. So now when we distribute that negative, 5x squared plus 5 minus 10x squared plus 4x over x squared plus 1 squared. And then when we combine like terms, negative 5x squared plus 4x plus 5 all over x squared plus 1 squared. Let's do another problem together, and then I'll have you do the check for understanding problem you're on your own. Our second problem is that we're going to take the derivative of 3 minus 1 over x over the sine of x. And now, before we do anything with this, we really need to remember to rewrite this. So don't do anything with the derivative. First thing we're going to do is say we're going to take the derivative of something that's the same thing. It's 3 minus x to the negative 1 over the sine of x. Here we have our f. Here we have our g. We're going to use our f prime g minus f g prime over g squared. Again, there's kind of a nice ring to it. F prime g minus f g prime over g squared. Let's do that right here. We're going to have our f prime g minus f g prime all over g squared. So this is 3 minus x to the negative 1 sine x sine x sine x. Derivative of 3 is 0. So we don't need to put that in, but we've got this negative, and then the derivative of x to the negative 1, negative 1, x, then subtract 1 from the exponent to the negative 2. Watch out, really tempting to make that be to the 0 power, but we've already started with a negative. Subtracting makes it more negative. Sine x is along for the ride. Derivative of sine is cosine. Right there. So now negative times a negative is a positive 1. This goes in a denominator. Sine x minus, and then this is 3 minus, x to the negative 1 is just 1 over x times cosine of x over the sine of x squared. For our purposes, that's probably about as simple as we want to get it. We can distribute this cosine over here to get slightly fewer parentheses. We could merge this to have sine x over x squared. You know, we might as well go ahead and do that. On the AP test, you don't have to fully simplify, so if you have it like this, you're really fine. But just for practice, let's do sine x over x squared minus 3 cosine x plus cosine x over x. Notice that we're distributing this cosine x here and this negative, so this term is going to be positive. We cannot cancel this sine x and this sine x because there is addition and subtraction here. So we'll just go ahead and leave it like that. Okay, to finish off, let's do a check for understanding problem. Your check for understanding is this. We want to find the derivative of sine x over 3x to the fourth. Go ahead and try that on your own. Pause the video now. Okay, so we've got the f prime g minus fg prime over g squared all written out. Now the derivative of sine of x is cosine of x. And 3x to the fourth is just along for the ride. Minus sine of x, and then this is 3, bring down the 4, that's 12x, subtract 1 from the exponent, 12x to the third, all over 3x to the fourth squared. We're going to either leave this like this, or since it's really easy to simplify, we could do 9x to the 8th. Either one is fine. And at that point, it's really pretty much simplified. There's not a whole lot to write out. So you can go ahead and leave it like that. Or if you simplify it further, that's fine as well. This concludes Derivative 5 notes.